Hello, all. Welcome to the second lecture for week three. This lecture, we're going to talk a little bit about integrated supply chain. So, at a high level, we're going to look at the problems with the traditional supply chain, the promise of the new supply chain, push versus pull versus push pull, integrating the supply chain, and the impact of the internet on supply chain integration. So, when we're looking at this traditional push based supply chain, forecast driven production and distribution. So the plan to build inventory ahead of time in anticipation of the forecast demand. So this is the typical model of we believe we're going to sell a million of these, so we're going to build a million plus 10% or 15% or whatever the business feels is that normal variance. So this is all good and well. The forecast gets consumed or not consumed by customer orders. So, but what we can run into is what if it goes wrong and all forecasts have a great chance of being wrong? And this could be it's wrong as you don't have enough, or it's wrong in that you have too much. Either way, you're going to lose profitability. So, a longer reaction time to the changing marketplace could cause you to be wrong. The inability to meet the changing demand patterns. And as we are now in a shorter news cycle, we're in a shorter flavor of the consumer cycle. We have more chances of our forecast going wrong. We have higher chances of obsolete inventory. And the obsolete inventory is what will cost you money and can bankrupt some companies. And that's why you see some companies go with legacy parts, the parts that are non-cosmetic. For example, Chevrolet uses the same steering system on like 8 models. Chevrolet uses the same chassis and steering system on the 2500 and 3500 pickups as they do the Tahoe and the Suburban. And then there's the bullwhip effect. Excess inventory, has a higher safety stock, and having higher safety stock has a higher risk of obsolescence. And the larger and more variable your production batches makes you more susceptible to this. And this bullwhip effect is that discussion of when you have this large variance, it eventually corrects itself and it can damage your supply chain. So if you are making too much inventory, it'll whip back and you'll have this obsolete inventory that is a problem for you. If you don't make enough, it whips back the other way and you have unacceptable service levels. So, and also, with the bullwhip effect, when we're looking at this, the impact of the bullwhip effect, it leads to inefficient use of your resources. So, for example, if you have too much, then you could be utilizing resources to figure out what to do with this excess inventory. Or if you don't have enough, you're chasing supply. So it makes planning and managing really difficult. And it can really, if you don't forecast enough and you're chasing supply, then all of a sudden you're in peak demand and you're air freighting. You're incurring costs for shipment that were not in your forecasted cost. So you result in higher transportation costs, higher inventory levels, and really higher manufacturing cost and a higher cost of goods sold. And anyone that's worked in that supply chain, finance, sales area, that COGS, cost of goods sold, is the Bible for how your profitability is going to happen. This bullwhip effect can really, really crush your profitability. So when we look at pull-based supply chains, some of the attributes, it's demand-driven. So you're pulling from your demand to determine what you need to do. And it's coordinated with a true customer demand rather than a forecasted demand. So you're staying more in tune with market trends. The firm does not necessarily hold any inventory on hand. It only is responding to those specific orders. So this is more common in make-to-order situations. Intuitively, it's attractive because you can reduce your lead times, reduce your inventory cost. It's a good, sound business model if you can get it right. However, if you get this wrong, it can be catastrophic. This can be really difficult to implement too. Long lead time parts are difficult to implement. So what you see is firms like this will carry a lot of work in progress. So you may have a lot of kind of these legacy components that are in progress. Um, and then when you get this order, then it just pulls everything in, and then it does that final assembly per the customer order. Um, and it is more difficult to take advantage of economies of scales because you're doing smaller batches. So you're not doing these large batch runs where the setup cost, the manufacturing overhead is spread over the smaller production batch. Um, so when we look at economies of scale versus economies of scope, that economy of scale, the unit cost of a given item falls as the volume increases. Your fixed operating costs are spread out over your larger quantities, as I just said, and then your supply chain implications. It's a higher volume reduces your unit fixed cost. You then, in theory, have a lower acquisition cost, which helps reduce your cost of goods sold. In economies of scope, you're using one versatile facility to produce many different products. So this is your classic high mix, low volume. Um, and with this, you're adding a lot of cost, but you could be getting a lot of sales because you have this flexibility. So really, you have to decide, do you want to be an economy of scale organization or economy of scope? What is your customer base? What are they demanding? How do you want to serve your customer? Push-based supply chains are going to be forecast-driven, whereas a pull-based is going to be demand-driven. Push-based is going to, goods are made before orders are received. They're made off of a forecast, that traditional forecast. Where in a pull-based, they're made when the order is received. They're based on true consumer demand. Push-based, we're looking at predetermined production schedules, whereas in the pull-based, they're reactive production schedules. Push base is a make to stock, whereas pull base is that made to order or that assembled order with those kind of ready made legacy subcomponents or sub assemblies. And then in the pull base, they're shipping to finished good inventory, whereas in the pull base, they're shipping once the good is made. Continue on looking at the benefits and the risk in that push based supply chain. You're slow to react to demand changes. You have a high risk of excess obsolete inventory. It requires a very high level of your accuracy in your forecast. This is ideal when demand uncertainty is low. So when you don't have a lot of variances, something that's very highly commoditized. Economies of scale are key to the success. However, in that pull-based supply chain, you're quick to react to demand changes. You have a low risk of excess. You have obsolete inventory. You require a timely demand visibility. And flexibility and speed are going to be your keys to success. And the characteristics that push-based supply chain. Your objective is to minimize cost. You're going to seek high asset utilization to drive down your fixed costs, leverage those economies of scale. You want to have long, high volume production runs with few changeovers. Changeovers cost money, and that changeover, the cost for that changeover, you're losing production time, and the cost of those techs are fixed overhead that are not tied to a revenue dollar. You have a complex supply chain structure, you have long lead times, and you have very minimal uncertainty. I mean, almost no uncertainty in your demand. However, in that pull-based supply chain, you want to maximize service levels. You want to be the difference maker for your customer. You want to seek flexibility. You want to be responsive, and you want your suppliers to do the same. So you simplify your supply chain. You're going to have short production runs, many changeovers. That's going to drive your cost up. It's going to drive your COGS up quickly. Short lead times, high demand uncertainty. So, when we're looking at implementing, a push-pull strategy, you're achieving the appropriate design. So you want to understand the complexity of your supply chain. You want to understand your lead times. You want to understand your relationships with your suppliers, with your manufacturers. You want to be close enough to integrate, but not so close they know everything. And there's a lot of different ways to implement. So that's just some high level stuff. As an organization, you're gonna, it's not a box that you get this box and it's your plan. You really have to start, adding pieces to it, and maybe it's a trapezoid. Who knows? So one thing to consider is when you get into this, in a professional setting, and you're helping look, what type of push or pull or push pull based supply chain. Don't be afraid to challenge. Don't be afraid to say, yeah, that's a key traditional piece, but it doesn't work for us. Let's find something that works for us. So when we look at demand driven supply chains, we want to minimize demand uncertainty. This is going to require, integrating that demand formation into your supply chain planning. Supply chain has to talk with sales. You have to talk with operations. So you can look at demand forecasting using historical data with some kind of variance calculation to develop that long-term estimate. Like, this is what we're going to do based on what we have done. You can look at what's called demand shaping, and this is when the firm determines the impact of the marketing plans, of consumer taste changes, of the pricing discounts, of the rebates, of running promotions, and really start to say, and this is how you calculate the variance that you can then apply to that historical demand. The push strategy is going to be a basis for planning before orders come in, whereas the pull is reacting to the orders that come in, and that push pull is really kind of a mixing of the two. So, and the impact of the internet on supply chains. You can't expect the internet to solve all of our business problems. It can solve some of them. Many people thought that there was problems in the internet-based business that were really related to logistics strategies. And e-commerce has a huge impact on supply chain. We're seeing that way that we can really, I guess one of the biggest things I like to think of is in supply chains, you now have such exact clarity in your lead times. And a prior company I worked for, they had this thing, I called it, Tetris. It was this AI program, and they were able to figure out the exact way to pack a container to truly maximize it and bring benefit to the organization. And then, really just by utilizing the internet, utilizing, and when I say the internet, I don't mean going out and surfing, but I mean utilizing integrated systems, interconnectivity of your systems. You're really going to have a lot more flexibility to service your customers, and in supply chain, our customers is manufacturing, our customer is operations and supply and the sales teams. So, I know that was kind of a pretty quick summary. This wasn't as long. This wasn't as robust of a slide deck as some of the other ones we go through. But I hope this gave you some really good information into when you're looking at supply chain integration.